something to do with subtended. Now, if we know who subtended who, now how do you think of subtend? Subtend, it's created, it's formed. So if we look at the following again, if you are going to do the following, what you have to check first is what is it that you are looking for. Whatever it is that you are looking for, you are going to check who's subtending whatever it is that you are looking for. Now, subtending, I usually think of it as who's forming this angle or who's protecting this angle. So in this case, if we take number F, on number F here, we are looking for X. So what I want to know is if I start from here at point B, if I can go from B, and then from B, I go with a straight line to the circumference. And then I see that I have point C here. And then I go again from B. And then it ends at A. Now these 2 points here, A and C, are the points which are going to be creating angle X here. So how is an angle going to be created? An angle is going to be created by 2 lines. In this case, our angle X here is going to be created by line AB and line what? And line BC. But now, who's subtending? Who's protecting this angle? Who's going to be protecting this angle? It's point C and point what? And point A. Now, if we say point C and point A, now we have a problem. Now, what kind of a problem do we have? As soon as you say A and C can be divided into 2 parts. It can be divided into, let's look at the following. I'm going to highlight them so that you will see. This is going to be what I call arc AC, this one. It's ACS. And then at the same time, this is not the only arc that I can have, which has AC. The other one that I can have is going to be this one. This is also going to be arc AC. So I have arc AC and then I have arc AC. Now you just said to me, sir, the person X, which is angle B is created by AC. Now the next question that is going to follow, which AC are you talking about? Because both of them are AC. Can you see that one again? We have the red AC, we also have the green AC. Now who's protecting now? The question that then follows is then, who's protecting angle X? Now I think of it this way, if I wanted to go to X, now how do I get to X? Who's going to be protecting X? Is it the red one or the green one? It seems as if the red one is going to be what to be protecting what X. I can't get to X unless I move past through this red thing here. But the other way to think about it is this way. The angle is always going to be looking at the protect. So the angle is going to be looking towards the arc which is protecting it. It can be an arc, it can be a chord. But in this case, we are going to be talking about an arc here. So our angle X, its opposite is going to be opposite whoever is protecting it. Does that make sense? Now, if we look at X, then it means which our X is going to be protected by this red thing that we are talking about. Now, that's what we are looking for. That's what we are looking for. Now, the next thing that you're going to do is to check what angle did they give you. Most of the time, they're going to give you a variable. Look for this variable, and then they're going to give you other angles that are going to help you to get to that variable. So the angle that they gave us here to help us so that we can get this angle X here, they gave us 230. Then I need to ask myself this question. Here's 230. Who's creating 230? Who's protecting 230? It's AC again? Yeah, we are right by that. But now which AC? Is it the red or is it the green? The what? If I wanted to go look at this thing, again, we said the angle is always looking towards its protect again. So 230 is looking towards green or is looking towards red. It's opposite red. Okay? So it means we can come and highlight this with a red color again. And then this one is also with a red color. And then they are protected by what? By the red arc. So if you're going to do this, make sure that you have colored pen so that you highlight all the angles that are protected by the same color. And then you highlight them whether they are at the center or whether they are at the circumference. Now, these 2 angles, because both of them are protected by the same person, then they have a relation. What kind of a relation do they have? The other one is at the center. The other one is at the what again? At the circumference. So if we have one at the center and then one at the circumference, what is it that we're going to say? We're going to start with the one at the center. We're going to say that we have 230, which is at the center again. I start with an angle at the center. The angle at the center is going to be equaling to 2 times my angle at the circumference. What is my angle at the circumference? It's X. Then what is my reasoning here? I'm going to tell them the reason why I'm saying this is because I have an angle at center. I have an angle at, it's not angles at center, it's an angle at center. I have an angle, it's 1. It's an angle at center, and then it's going to be equaling to 2 times an angle at circumference. Okay, now I want to get x again. How would I get x? Divide by 2. If I divide by 2 both sides, it says my x is going to be equal to 115. So it's 115. So if you do something like this, they will give you 1 mark for statement and reason, 1 mark for the answer. Okay, now what else do you want to know? I put these 2 questions on papers next to each other so that we can compare them. Now, how do you approach the question? I said to you, what we are going to do, you're going to start with whatever it is that you're looking for again. Let's go and look at this one. We are looking for x here. Now, who's creating x? AC. But now, when we say AC, you are broad again. So we're going to say, who's creating AC? Who's creating x? X is created by AC. Now, this AC is going to be divided into 2 parts. It can be green one, and then we can call them major one and the what, and the minor one. So if we continue with that, then we'll come and say, okay, this one here. And then we can also have another one. So we'll have another one, which is going to be the green one. Okay, now that we're here, X is going to look towards its protector. So X will be looking towards its protector. So who's protecting X now? Is it the red one or the green one? So X is protected by what? By the red one. Okay, good. Now let's check here. We also have, after looking at the angle that we are looking for, we're going to check the angle that is given now. There's an angle which is given, which we are supposed to use to get X in other ways. Let's go and look at 150 now. There you have 150. Now, 150, the angle is always going to look towards its protector. Now, who's protecting 150 now? Now, here, look at what happened with this one here. We both of them, this 230 and this one here, they were both protected by the same color. Both of them, they were red. But now, in this case here, we have a problem. The other one is protected by the red one. The other one is protected by what? By the green one. So I can't say this one here. And then that's what most of us did. I can't say this one here is going to be twice this angle. It doesn't work because they are not protected by the same color. In other words, they are not both protected by the major arm, or they are not both protected by the minor arm. Then it's a problem. How then do we solve this problem? What we can then do is to come and calculate this angle here. Let's look at this angle here. Can you see this angle here again? And then this angle is going to be looking towards its protect. Who's protecting this angle now? The red. Now look, who else is protected by the red? Who else is protected by the red? X. So X is protected by the red, and then this angle here is also protected by the red. So those 2 angles, they have that relation of angle at center is twice the angle at the what again? At the circumference. Then the problem is then, how then do we get this one here? That's the challenge. How would we get that one? Now, if you remember from earlier grades, if you add these 2 angles, they're going to give you something which we call a revolution. Now, a revolution is 360. So we'll start by that. We'll start by saying, if I to add 150, if I add 150 plus 01, they're going to give me what? 360 degrees. And then I need to state the reason why I just can't say things in Euclidean geometry. So why am I saying this thing here? This thing here, you can say which are angles on a revolution, or you can say which it's angles around the point. So any angles around the point, they are going to give you 360. Any angles around the point, they are going to give you what? 360. Then it means, in other words, I can get this angle here. If I say this one and this one is going to say 01 is going to be equal to 150 minus 360. What do you get? 360 minus 150. It gives us 210. How do we get that? Again, if we said the 150 is positive, if you check the 150 to this other side, it's going to become what? Negative. And then it says here we're going to have 210. Meaning here, Yeah, it's 210 degrees. Then here we can come and say this angle here, this whole angle here, starting from here up until there. This is going to be given as well as 210. Now, we can clearly see that we have an angle at center. What is the angle at center that we have? 210. Then we'll come and say, okay, we have 210, which is going to be equaling to 2 times x. Now, what is going to be the reason that we're going to quote there? We're going to quote the same reason here. So I'll take this reason and put it here. Angle at center is going to be 2 times the angle at the what again? At the circumference. And then I divide by 2, It says, what is going to be our x? It's 105 degrees. Then, how would we mark such a question? Before we mark, let's do the following. You come and try the following as today's activity. So you do this one now.